Welcome to the lecture series on deep learning techniques in medicine. So, I am Dr. Sivaranjini, Assistant Professor in the Department of Biomedical Engineering, SRM Institute of Science and Technology, Katangarattur. Today, in this lecture, we will be seeing about Module 1, which covers Introduction to Deep Learning. Okay. What are the main contents of Introduction to Deep Learning? Are the neuron expressing linear perceptrons as neurons and the linear models. We have the logistic regression, linear neurons limitations, and a simple DNN model. And the activation functions for these deep learning networks, such as the sigmoid, tanh, ReLU. And we have the fully connected layer and the softmax output layers, which are required for the deep learning networks. And we also see about the deep learning libraries such as TensorFlow, Keras, and PyTorch. So, and we also covered about the training sets, test sets, the validation sets, and the hyperparameter tunings for each and every set. And a small example about the feed-forward neural network and how it works. So, getting into the contents of this module, we have the neuron. Okay, so moving on, before moving into this particular lecture, I just want to give a brief introduction as what is deep learning. What everyone is learning about is very fascinated about deep learning. And what is this? Okay, we can see as a simple example. So you imagine just a teaching, just you are trying to teach a computer to recognize a cat. Okay, so instead of writing thousands of rules like how the cat look like you, so you can say that the cat have whiskers, you have the cats have pointed ears, and we let the computer learn these patterns automatically from the data rather than giving each and every thing as the rules. Okay, so this is what is called deep learning. It eliminates the requirement of rules. Instead, it makes the system to learn what these things are. Okay, so on an what can be the possible applications of deep learning? So you have your mobile and you have a face unlock into your mobile, and many people nowadays are using ChatGPT as a very famous AI tool. And we have self-driving cars. Tesla cars are self-driving cars where they drive on their own. They don't require a driver. And an important in the medical field, medical diagnosis is done through deep learning automated networks. Okay, automation for medical diagnosis is possible through these deep learning networks. And another major thing is like speech assistance. We have this Google Assistant. We have so many speech assistants where we are able to input our voice and get the work done. Okay, all these are the deep learning models. So we have heard all these jargons as artificial intelligence, machine learning, deep learning, all these are there. So what is this artificial intelligence? So these are the machines performing tasks that require human intelligence. Okay, so this can be a major portion which occupies, where machine learning will be a subset of the artificial intelligence. So it learns from patterns, and it learns the patterns from the data instead of doing an explicit programming saying this and that. Okay, instead of saying by rules which the AI does. Okay, so going in deeper into it, we have the deep learning models, which are a subset of the machine learning models, where these are the layered neural networks that learns complex patterns automatically. So they don't need human intervention to say, okay, this is this, you have to segregate and give me. No, that is not required. So it learns the complex patterns automatically and gives you. One example, some of the few examples which I can quote for AI are, we have the system playing chess, right? That is an AI application. Okay, it learns, the system has its own rules When we are playing, the rules are applied and the system plays with us, right? So that is one of the AI application. ML application can be detection of spams in mail. Okay, so when you receive a mail, it can be segregated into a spam or a non-spam, right? So this is an important application of an ML model, a machine learning model. What can be a DL model is like every day we are using this image recognition task, where if we want to open our system or if we want to open our mobile, we show our face and it detects our faces, it recognizes the image of our face and it is giving a yes or a no to the system. Okay, this is the authenticated person for the mobile, let me open, right? So these are the applications of a DL model. Okay, so how are these deep learning models built? Okay, how are these deep learning models? And every deep learning model that is built is from one basic unit, which is called the neuron. Okay, so we'll be seeing like what is a neuron. So neuron is a fundamental computational unit of a neural network, which has been inspired from the biological neuron, but it is mathematically modeled to perform computation on numerical data. Numerical data in the sense the inputs that we give to the neural network. So in artificial neural networks, a neuron receives multiple input signals, combines them using weighted connections and produces an output after applying an activation function. Okay, we'll see in detail what are these inputs, what are the weighted connections, and what are the activation functions to be seen. Okay, each input to a neuron represents the feature of the data and each feature is associated with a weight that indicates its importance. So each weight, each input will be a feature to the network. Okay, so each feature will have a weight or an importance, how much important that particular feature is. Okay, so based upon that only we will be able to compute, right? And moving on to the mathematical computation, or we can see that different points or inputs are given to a neural network, right? So here it is mathematically represented as y is equal to f of w into x, right? So what is this w? Is the weighted sum, right? Weights that are given to the particular input feature which you are giving. Okay, so the neuron computes a weighted sum of all these inputs, which represents the total simulation received by the neuron. And so this aggregated value will be passed through the activation function to generate the final output of the neuron. Okay, so this activation function will be before the output to say if the decision is an yes or a no, right? Moving on to the different portions of a neural network, we have the input, the middle portion, which computes the weights and which computes the weights along with the inputs, the weighted sum which got, and then it is transmitted through to the activation function, and then the output is obtained. Okay, so now the input layer of the neural network is the only one which transmits the data and does not perform any computation. No data computation, nothing is performed in this input layer. Okay, so the computation, where does the computation occur? It occurs in the output or the hidden layers, where we have the weighted sums and the activation functions to do the intended job. So different choices of activation functions allows the neuron to simulate various traditional machine learning models, such as the linear regression, logistic regression, and the support vector machines. So on the whole, we can see that the building blocks of the neural networks are the neurons, and complex deep learning models are constructed by combining many such neurons in a layered architecture, right? So the graph which says that as the amount of data goes on increasing, we are getting a better accuracy level in various tasks that implement the deep learning models. So we shall see like a small example where we have a loan approval. Okay, So the bank wants to know that if I am going to approve the loan for that particular person based upon various features or various things that the person holds on, right? So here we will be having for the bank to approve it, the bank employee must know about the person's age for whom the loan is going to get approved or not approved, right? The person's age, the income of the person, the credit scores for which each and every bank requires, right? So all these are the inputs. What are the inputs? Income, age, and the credit scores are the inputs that are given to the deep learning models. So what are the weights? So what did I tell you before? Like, weights are the importance of each and every input that goes into the network, right? So here we are having the inputs as income, age, and credit score. These are the three inputs which we are giving for a loan approval prediction, whether the person can get the loan or not, based upon these factors. Out of this, the credit score seems to be the highest weight because it is of highest importance rather than the income of the person or the age of the person. So bank people prioritize, the bank employees tries to prioritize this credit scores as the major input factor given to the network, right? So then it computes the weighted sum. Okay, it is a single number summarizing applicant profile. Single number summarizing applicant profile in the sense we are trying to multiply the weights or the importance of each and every input to each and every other input. Okay, if this income is of least, if the age is of least importance, it is given a weight. Okay, this is the least important weight. Okay, least important feature. Income will be the next least important feature, but the most important feature, the credit score, will be given a higher weight that will be added along, that will be multiplied and summed up along with the other weights too, right? So the activation function will be the one which will tell you that it is approved or not approved, right? So moving on, we have expressing a linear perceptrons as neuron. Okay, what is this perceptron? So we have the perceptron as a simplest neural network with only one computational layer, right? Simplest neural with one computational layer in the sense they don't have any hidden layers or they don't do very complex tasks, right? So it is a linear combination followed by a signed activation function. The neuron receives multiple input features, combines them linearly using weights called as linear threshold units. Okay, the neuron performs the entire computation and input layer only transmits it, right? So it will be as a threshold will be set. Okay, the output will be when it is above the threshold, output will be a S, or if it is below the threshold, the output will be a reject condition or a no. So S or no depends upon this threshold, like how much is my value at the output, right? So mathematical representation of a perceptron neuron. What is the mathematical representation, right? So we have the weighted sums to be W1, W1, W2, W3, it goes on till Wn, right? The weights of the particular input. So the inputs will be X1, X2, and it goes on till Xt, right? So the output will be a binary class label. Either it can be a -1 or it can be a +1. So it is a sign function for a perceptron as we saw before, right? So the weighted sum will be calculated and it will be given. So the weighted sum computation will be calculated as W into X, which is a summation of I to D, Wi into Xi. So the output prediction will be this weighted sum computation along with the sign function, right? This sign function converts the real valued weighted sum into a binary class label, right? So if we are having only two linearly separable data, a perceptron can work. right? So moving on to the incorporation of bias in the perceptron neuron. What is this bias? Bias is nothing but a, a point which tells you that we have to shift the decision boundary or not. It is able to shift the decision boundary. What is this decision boundary? It's like we are trying to give a boundary below the threshold. This will be the result. Above the threshold, it will be an S, right? This is how it is calculated in a perceptron, right? So this will be the decision boundary, which will be a linear decision boundary in a perceptron, right? So this bias will be a one which shifts the decision boundary, and without this bias, the boundary is forced to pass through the origin only. It cannot be above or below, right? So in some classification problems, the decision boundary does not pass through the origin. There might be situations where the decision boundary has to pass from somewhere else, right? So to account for this, the bias term was introduced, right? The prediction with bias will be going as y is equal to sine function of w into x plus b. Previously, we don't have this plus bias term, okay? So this neuronal output will always be a constant value of 1. Why? Because if in case the inputs are 0 by some means, the bias term, which will be always as 1, will be given to the network so that the output does not become 0 and some constant value of 1 is given as the output, right? So this approach allows the bias to be treated like any other weight during the training phase of the network. So the common step function that is used in the perceptron is the Heaviside step function that is used for the linear computation inside the network. So moving on, we will be seeing about how the perceptron will act as a linear classifier. So as I told you already, the perceptron neuron implements a linear decision boundary of the form w into x plus b is equal to 0. B is a bias term, w will be the weights that is there, and x will be the inputs. W into x will be the weighted sum, which means each and every input is multiplied with each and every weight, and then it is summed up as a total. Okay. So here in a linear classifier where the perceptron is used, this equation defines a hyperplane that separates the input space into two regions that is corresponding to having two classes, right? So on the whole, the perceptron separates the data using a straight line, or it is called as a hyperplane, that is represented with wx plus b is equal to 0. So it works only for linearly separable data, and if any other data which is not linearly separable, for example, an OR gate might be a linearly separable data. The inputs in the OR gate, if you plot it, it will be a linearly separable data. AND gate, it will be a linearly separable data. But if you go for an XOR gate, the data is not linearly separable and it fails when we are trying to classify it as zeros and ones with a perceptron. So what can we do for this will be covered in the next video lecture, right? We will be seeing about the multi-layer perceptron and how the stacking of the neurons solves what a single perceptron cannot do. Thank you.